We've covered previous year questions from Fundamental Theorem of Arithmetic in our previous videos. Now let's move on to proofs of irrationality of root 2, root 3 and root 5. The questions asked from this section are usually for 3 marks. In this video, we'll be covering the proof of irrationality of root 2. This was asked in 2010 for 3 marks. Series details have been provided for your reference. The question is, prove that root 2 is an irrational number. It's a 3-mark question. The method used here is called proof by contradiction. In proof by contradiction, we start with the assumption that the statement opposite to the statement to be proved as true. The statement to be proved here is root 2 is an irrational number. So we'll assume the opposite, that is root 2 is rational. So let's assume that root 2 is rational. All rational numbers can be expressed in the form p by q, where p and q are integers and q not equal to 0. And these fractions can be reduced to its simplest form by cancelling out all common factors. And such a fraction will have the numerator and denominator as co-primes, or they will not have any common factor. So let's express root 2 as a fraction of co-primes a and b such that b not equal to 0. So we've expressed root 2 as a fraction of co-primes and therefore a and b do not have any common factors. Now let's take b to the other side. We get b root 2 is equal to a. Now let's square both sides. So we get 2b square is equal to a square by squaring both sides. And this is our equation 1. Now 2b square equal to a square means that 2 multiplied by some number is equal to a square, which means 2 is a factor of a square. So therefore 2 is a factor of a square. If 2 is a factor of a square, it implies that 2 is a factor of a. This is from a theorem that we studied in the chapter. If a prime number divides a square, then it also divides a. So we've got 2 as a factor of a, and this becomes our statement 2. Since 2 is a factor of a, there should be a number c such that a is equal to 2c. Now let's substitute this value in 1. So substituting in equation 1. What is equation 1? 2b square equal to a square. So instead of a, we have 2b square equal to 2c the whole square. This becomes 2b square equal to 4c square. Cancelling 2 here, we get b square equal to 2c square. So b square is equal to 2 into some number. Therefore, 2 is a factor of b square. If 2 is a factor of b square, 2 is also a factor of b. And this is from the same theorem. If a prime number divides a square, then it also divides a. So this becomes our statement 3. From statement 2, we have 2 is a factor of a. And from statement 3, we have 2 is a factor of b, which means 2 is a factor of both a and b, or therefore from 2 and 3, 2 is a common factor of a and b. So from 2 and 3, we found that 2 is a factor common to both a and b. But we assumed initially that a and b are co-prime. So we've arrived at a contradiction here. So this is a contradiction to a and b are co-prime. The contradiction has emerged from our incorrect assumption. Therefore, A and B are not co-prime. This is due to incorrect assumption. Therefore, we've proved that root 2 is an irrational number. So the method used here is called proof by contradiction. In proof by contradiction, we assume that the statement opposite to the statement to be proved as true. Here the statement to be proved is root 2 is an irrational number, so we assume that root 2 is rational. Rational numbers can be expressed in the form p by q, where p and q are integers and q not equal to 0. By cancelling out all common factors, we can reduce p by q to its simplest form, where the numerator and denominator will be co-prime. So we've expressed root 2 as fraction of co-primes a and b. Taking b to the left hand side, we get b root 2 equal to a, and squaring both sides, we get 2b square equal to a square. Therefore, 2 is a factor of a square, which also implies that 2 is a factor of a. If 2 is a factor of a, there should be a number c such that a is equal to 2c. Substituting this value of a in equation 1, we get 2b square equal to 2c the whole square. Simplifying, we get b square equal to 2c square, which means that 2 is a factor of b square, which also implies that 2 is a factor of b. From 2 and 3, we understand that 2 is a factor of both a and b, or 2 is a common factor of a and b. This contradicts our assumption that a and b are co-prime, and this contradiction has emerged from our incorrect assumption. So our assumption is wrong, and therefore root 2 is an irrational number.